Okay, Hickok 600A tube tester with an added milliamp meter for the plate current. This meter can go from negative 200 to positive 200. And when I installed it, if you're looking at the pictures, you'll see all the readings from the 6L6 and the 83, the 12AX7 and the 6AQ5. The milliamp readings are negative. So I thought I had remembered how this was hooked up. It's supposed to be hooked up by the colors of the wires, and I got it backwards. So I'm going to make this video to show you, if you buy this tube tester, you're going to want to know how to disconnect the milliamp meter, because you can't just pull this off of here, because there's wires going underneath into the milliamp meter, and if you just rip it out, you're going to rip those wires out too. And I put a little kickstand in here, which I didn't put in for the consumer or the person who buys this to use, but I'm leaving it in there. It's really not too safe to use it, but it's there and I can use it, and I just use it for a second. So here's what you need to do. All the screws are out, of course. It's unplugged, and I just pull up on the test button, the short and the test, just a little bit to get my finger underneath the chassis. Lift it up, and here's a little kickstand I put in here, which just I mean, it could, if you bump this, it's gonna fall, so I would not use that. And so what I would do is I would use something like these sticks, or you can use a screwdriver that goes into the hole for the screw. Make it pretty stable so it doesn't move around. And the quick connect fitting in here is just floating around. It's safe where it's at, and I'm going to take this apart right now and pull it out. So when I hook it up the correct way, when I put it back in, it'll show positive when it's supposed to show positive. So now that that's disconnected, you can pull the chassis off. So there's inside of it, and the hole right here also gives you access with a long enough screwdriver to the quick connect fittings inside that connect to the battery and connect to the meter. So everything has these quick connect fittings, rather than soldering all these wires together. I thought it'd be easier to do it like this. And if you do happen to pull something, you'll probably just pull the wire from the quick connect fitting. So there's what's sitting down there, and it's just floating around in here. Rather than mount this, and if you forget and you pull, you have a little bit of wire in there. You're going to be able to come up this high before you start pulling these wires out. And it just sits over here in the corner. It's out of the way. It's underneath this meter. And you can see these wires are tied in with the rest of the wires on the tester, and it's away from the tubes as well. Also, this knob right here, this will come in handy when you lift it up like that. Don't use the kickstand. You know, it's there. I mean, you can use it, but I wouldn't. If you prop it up like I showed you, you'll have easy access to the line adjustment control. Although a 600 and a 533A do not have a line adjustment control, I put one on this one. And it's set right now, and you know, you don't have to lock it down unless someone's going to get in there and turn this. This is going to be fine. It does not have to be locked down. So I just made it convenient. If you want, you can take the knob off, whatever. And the meter, I left that bar off of it, which does absolutely nothing. If you watch the video and you say you want that bar, I'll send it with the tube tester. To me, they're just a pain, and they attract corrosion. So here's the case. I'll tell you a little bit about the case. It's handmade, solid wood, 3/4 inch, or excuse me, yeah, 3/4 inch upgraded wood. There's not one knot in it. And it is stained black. The outside is stained black. The tops here are stained black. I painted the inside, and I painted the inside of the cover too with black. But this is stained, and I put I don't know how many coats of polyurethane on this after it was all put together. And I had to do one coat at a time. Top, side, this. It was sort of a huge pain in the ass, but it's stained in polyurethane. And the hardware is heavy duty. You can see how the handle's held on there. It's a Penn Elcon handle, which is literally desprung. I cut the spring out of it. I do not like the sprung handles for this particular type of device. And I put some heavy duty hinges on the back. Everything's black and the cover comes off real nice. I didn't put a hinge support here to leave the cover up. If you want, this is something you can do yourself if you're interested in doing something like that. And one other thing I'd like to mention before I hook this all back up and test a couple tubes is that all the screws can come out. The handle comes off, this comes off, these come off, the latches come off. Everything can come out, because normally if I was going to do this and keep it, I would put a dab of wood glue, sort of like Loctiting these screws in. And I didn't do that because it's possible you want to paint this a different color. So that's why I don't do that. It's not that the screws aren't in there tight. They are. Every one of them's tight. I just leave it so they're easy to come out. If you want to make any kind of changes to it, painting, it's easy to get all this hardware off so you can paint and put it all back on. If you want to Loctite those screws down, go ahead. So I'm going to hook this back up, and I'm going to put the blue here to the black and white wire, and the black and white wire to the blue, because I thought the blue was the load and it's not. The blue is not the load, the yellow was the load, and the yellow transformed into a black and white wire because I have no yellow wire left. So the load wire is the black and white wire. And so I just got to change the load to the black and white on this clip here. And again, the other clips that are all mounted in here are easily accessible with a screwdriver. It's sort of a pain in the ass, but it's not that difficult if you have the right size screwdriver, just a regular Phillips head number 2. The 200 milliamp meter has its own power source, so it's not hooked up to this tube tester in any way. It's controlled by a 9-volt battery. You can go AC DC with this, hooking it up 8 to 12 volt. This is hooked up to a 9-volt battery DC. The battery is velcroed to the side. When I ship this, I'll put a little foam in here to make sure the Velcro doesn't come loose. Okay, so you have the chassis out, you want to put it back in the case. So, pretty simple. I'm leaving this down. Like I said, I almost feel like I should take this out because it has just a very small lip. I was going to add another little piece of wood on here to make it a little bit more stable, but that's up to you. It doesn't bother anything. It may come in handy for somebody, so I'm just going to leave it in. Couldn't have put the chassis in. You always slide in the transformer side first. I have this up. I'll use my bamboo stick here. Stick it in the slot. Stable. Screwdriver works good too. And in the same screw hole. But I want a little bit of height this time. So now I am going to hook this up so we get positive readings instead of negative. We're going to go blue. Very simple to hook up. Nice quick connect fittings. Very tight, very stable. And that's it. Okay, I'm testing an 83 Mercury rectifier that I tested. I probably don't have room enough in the pictures to post it, so I'm going to test that one here. All the controls are set. JR03000. This is checking plate 1. Rectifier, you can't check GM, mutual conductance, transconductance, whatever you want to call it, because there isn't any in a rectifier tube. And the shunt or English is set at 62. The bias is at 0. And let's check for shorts. Always got to check for shorts. Little flash, you want to see that once in a while, that way you know the bulb's good. Just a little left over in the capacitor that flashes once in a while. Nothing to worry about. We're on another tube test, we're at the line. Let's check that line. Just about perfect. So, here's a big mistake people do when they're checking a rectifier. They press the GM button. What's going to happen, that fuse is going to light up and that meter is going to peg. It's going to be like all hell breaks loose. You got to be real careful. This is a big mistake. It's easy to make. I still make it to this day. If I'm not paying enough attention, I'm going to test the tube. I'm so used to pressing the GM button. All of a sudden I'm testing a 5Y3 or an 83 and I go ahead and press the GM button. You got to press the rectifier button. Let's see what we get here. And definitely in the good side. And this 83 is jumping around. This is a used 83 I took out of an old tube tester. Looks like it's burning okay. That is plate 1. And the milliamp 39.7, 39.6, about 39.6. Let's see what plate 2 has to say. Plate 2 is JR02. Anyways, let's check for shorts. You got to check for shorts on each plate or each side of the tube, each triode, each pentode, whatever it is. If there's more than one, you got to check for shorts on that particular section of tube. No shorts. Check the line. You got good lines, good meter, holds the line real good. It's not all flopping all over the place. We're on 62. We're at 5 volts. All right, rectifier. Milliamps 36.2. Looks like this plate is a little bit more stable. I've tested this tube several times, so these results aren't shocking to me. That's why that tube's not in a tube tester. So let's get out another tube and test it. And we move this 12.6. We set the bias to 12. I set the English to the GM rather than the emissions. Emissions on this would be at 58. And I am at 74, which is checked for GM on a 3000 scale. And I set it EV76080. And this is for triode number 1. Now we got to get the line. I know I'm way down on that. Let's bring it up. Heat the tube up. Let it heat up a couple minutes. While we're letting it heat up, you can check for shorts. I know it doesn't have any. I've tested this tube many, many times. Matter of fact, I just tested it yesterday. See what the line's any different there. It's warmed up a little bit. Gotta let tubes warm up. Okay. We're on 3000, we're on 12. We checked for shorts, checked the line. 12.6 EV7608. Okay, triode 1 is 1800 on the nose. It's right where this tube should test at. Milliamp 4.0, 4.1. So it bounces from 4.0 to 4.1. Alright. Okay, let's go to triode number 2, EV2103. 2103. EV21030. 12. Same thing, 58. So in the 600, Hickok 600 gives you average new old stock GM readings. And an average new old stock 12AX7, each triode should test at 1250. As you saw, that's 1800, and I get 1800 a lot from this particular tube. There's a variance. I have it written down someplace, like from this much to this much on different tube testers. But more often than not, I'm getting around 1700, 1800. All right, let's test for shorts on this triode. No flashes. We're good with shorts. Check that line. Line looks perfect. Okay. Now we're going to check triode number 2. It should be right about the same. Maybe a little bit less on triode 2. It is a little bit less. It is 17, 15, 16, 17, 18. That's a little bit higher. 1875, right below the 1900. So there you go. Nice meter, and milliamps 4.0. So there we go. Plate current, milliamps 4.0 on each triode. Each triode comes out, I forgot what the first one was. I said 1800, I think it would have been 1900. Yes. So one is a good 12AX7, no problems testing any of the triodes. Didn't have to wiggle it around or anything. A lot of times you have a bad socket. If you bend the tube a certain way, you can get it to connect. No problem here. And we'll test one more tube. We're going to test a 6AQ5 using the 6000 scale and the 7-pin min socket. Alright, we reduced this down to 6.3. It's supposed to be, according to this, 6.3. 6AQ5, 6.3, JR35620. JR35620. Bias is at 10, English is at 86. Well, I'm not setting English at 86, I am setting it close to that. Setting it to the 6000 scale, which is 87 on this. And we're all set, we're on 6 volts. We're going to stick the pin in. Let's see how far we're up on that. Lower it down to the line. 7-pin min in. And let's see, give it a minute or two to warm up. While it's warming up, we'll set the line and check for shorts. Again, I know this tube doesn't have any shorts, but it's a good habit to get into. Anytime you test a tube, you should always test for shorts first. You can ruin a perfectly good tube tester by testing a shorted tube. I don't know if you can see it, but the tube's heating up. Alright. There's only one section on this tube. Alright, let's check for shorts, if I didn't already. Line adjust. After the tube's nice and heated, that's when you want to recheck the line. Okay, 6AQ5. All warmed up, we're on the line, perfectly on the line. Expect around 4900. We got 5200, and we got plate current of 41.9, 41.8, 41.7 milliamperes. Somewhere around 41.5 milliamperes. Settled in at 41.6. 5200. Okay. So that 7-pin min tested fine. This is a good working tube tester with a milliamp meter. As you can see, the tube, it'll still test. You get the same exact results with the meter on or off.